All right, in our last video for section 3.7, we're going to write equations of lines from a word problem. We're going to be given some information. We're going to try to take some of that information, write an equation of a line. Even though maybe the data might not be exactly linear, we can take and make an equation of a line of best fit that kind of represents the behavior of the graph, of the information, and then use it to make predictions. If you look at example 3, it says the percent of children ages 3 and 4 who are enrolled in nursery school has decreased from 54.5% in 2007 to 52.4% in 2009. Part A wants us to find an equation for the line containing the data points. Let X represent the number of years after 2000 and Y represent the percent of children ages 3 and 4 who have enrolled in nursery school. So our X is our independent variable. Years, time is typically independent. And then our values are our dependent variables, our Y's, even though it's not written in that order. So don't let that confuse you. So what we can do is we can take the information from up above and we can make really two ordered pairs. We're given 2 times, years, X's, and we're given 2 percentages, our Y's. So it always helps me kind of write it in an ordered pair. So my first ordered pair would look something like this. 7, 54.5. You notice that I didn't put 2007 because in the problem it told me to represent X as the number of years after 2000. So if I'm talking about 2007, it's really 7 years after. So I'm going to use 7 instead of 2007. So my X value of that coordinate would be 7. My Y value would be 54.5. That's the percentage of students. So what do you think the coordinates of that second data point would be? Did you say 9, 52.4? All right, now that I have these 2 points, it might be easier for me to see that I have just 2 coordinates, and now I can come up with an equation of a line, just like we've done in the past. I can find a slope and a point and use them to write the equation of a line. The first thing we can do is find the slope. Remember, anytime we're given 2 points, we can always find the slope by using our slope formula. I have my y2 minus y1 over x2 minus x1. You notice that I actually labeled it too, so I know what it actually means in context of the problem. The y values are percents, and the 9 and 7 are my years. So when I actually divide and find a slope, what this really means is it's percent per year. It's a rate of change. We've talked about that in the past. So it looks like my slope, or my rate of change, is negative 1.05% per year. The amount of children being enrolled is going to go down by approximately 1.05% each year. That's my slope, or my rate of change. Now let's take our point, any one of them, and plug it into our point-slope formula so we can find the equation of our line. I have my y minus y1 equals m times x minus x1. You notice that I use the first ordered pair. It doesn't matter. We should still get the same one if you chose the second ordered pair. I'm going to go ahead and distribute my negative 1.05 through. I'm going to go ahead and add 54.5 to both sides. And I ended up getting y equals negative 1.05x plus 61.85. The 61.85 would be representing my y-intercept if I start at 0. And then my negative 1.05 would represent my slope. Remember, it's decreasing by approximately 1.05% each year. All right, now let's do part B. Part B asks us to estimate the percentage of children enrolled in nursery school in 2008 and maybe then in 2012. So what we could actually do is use the equation of our line that we made from part A and use it to estimate what's happening in 2008 and in 2012. It might not be exact, but it would give us a pretty good idea of what's happening in those 2 other years. Remember that 2008 is a year, so it's an X value. But we're not going to say 2008, we're just going to say 8 because that's how many years after 2000. And remember, for 2012, we're going to use x equals 12. What that means is I should be able to take x equals 8 and substitute it into our linear equation from part A. I should be able to substitute in x equals 12 and figure out approximately how many kids enrolled in nursery school. Let's do that. Let's plug in an 8 for x, and let's plug in a 12 for x, and then let's simplify. Remember that y was the percent, and so when I ended up getting these 2 percents, in 2008, I can approximate that there was about 53.4 5% of students enrolled in nursery school. And then in 2012, a little bit later, there was only 49.25% of 3 and 4-year-olds enrolled in nursery school. You can see that it makes sense that from 2008 to 2012, the percent should be going down, right? It's a negative slope where it said it was decreasing. So your numbers should make sense in context to the problem. Make sure that you have them labeled so you know exactly what it means and they're not just numbers.